Hello, everyone. Hope you all had a wonderful New Year. Today, I would like to show you how you can use SharpCap to take some old data that, in my case, are in AVIs and convert those AVIs in pip into a Ser file. And I'm not going to do a lot of processing in pip. I just want to I want to join all these files. Then once they're joined, I'll import them into SharpCap to start processing. And I'm going to use this data to simulate a live real-time processing that SharpCap is able to do. So the first thing we'll do is some real quick basics. I'll jump into my remote desktop machine. And before I do that, let's go back to here. And photos, and I want to copy this. Now, this paste it. This is the PC that is going to be doing the processing. This is on my Pegasus NYX-101 mount. This is a carbon fiber tripod with the risers and the mounts up here. And what I want to show you is the PC. This is an HP Elite Desk. And if you spread your hand out and put it on top of this unit, it just about covers your hand. It's like 8.5 by 8.5 by 2.5 inches. And this is got an i7 in it. And I will show you. And the reason why I want to show you this is that this is the machine that's going to be doing all this processing. This would be the machine that if under normal conditions, whether it's solar, lunar, or planetary, this machine would be doing this processing in real time. It's I picked it up off of eBay. These are enterprise machines, and generally what happens is some company is going to be upgrading their machines, and all of a sudden all their old machines wind up on eBay. So you can get this machine between $250 and $500 depending on the specs. This is an i7, which I'll show you right now. Go to about. So this has got an i7 8700 CPU. It's got 16 gigs of RAM. I happen to have 2 hard drives on this system. One is, let's just open this up and go to this PC. So I've got one that is a 256 gig hard drive for the system. Then I've got a 1 terabyte data drive, and then I just happen to have, this is my drive that I throw all my old data on, and I just throw it up on a shelf, and when I want to access it, I plug it into a computer. And this is currently plugged into that little mini PC. So that's the information on this PC. It's not a real killer, but it's got 6 cores or 12 threads. So if we go into here, you can see that it's got 6 cores and 12 logical or 12 threads, which makes this machine very nice for what it's doing. So again, you can find these machines on eBay. Just type in HP Elite S or Elite Pro, anything like that. You'll see all kinds of stuff pop up on the for your search results, and then you just pick the one you want. And the reason why I like to use eBay for stuff like this is they've got a very good return policy. So if you happen to get a lemon, you can either get a replacement from the company or you get your money back. So I find that for the money that I've spent on these PCs for my mounts, various mounts, I have 3 mounts with 3 PCs. And I spent relatively a small amount of money for having the mount being controlled by its own PC. And they're still cheaper than like an Eagle or some of the other controllers that are out there. The ASI Air is very limited. It's strictly ZWO all the way. And then there's a new one, I forget what it's called. It's like $600, but it's got a wimpy little piece GPU in it and CPU. So I prefer to just stick with what I know, and that's the PC. So the first thing we're going to do is I'm going to open up, browse to my Mellencamp folder, go to 2021, and the first place we're going to is 924 right here, and I have some Saturns. And we're going to look at now, now that I'm switching this stuff over to SharpCap, I no longer need to make a bunch of little files. I can make one big one and then process that in SharpCap, and it would be basically what I'm going to do in pip. We'll just take a quick look at this. So this is Saturn. You can see it's jumping around. I'm just barely making out the, I think that's the Cassini division. Not sure. Don't rip me up if I'm wrong. And this is from the 7th. Let's just check and see if the 8th is any, or the, this one might be a little better. We'll use the 8. So what I want to do now is open up pip. And the reason why we're going to open up pip is I need, SharpCap likes SER files, not AVIs. In fact, it doesn't even see the AVI files. And for all those interested, AVI files are for all intents purposes dead. So I would get off AVIs and start using SER files. Whoops, I opened up the Poll Master by accident. My bad. So this is a rather new version. It came out, I believe it came out in, I'm not sure. It says 2017, but I know that I just got this, and it was listed as new in August, I think, of last year. I'll put the links for pip and SER player in the down in the description. So what I want to do now is I want to grab all of these videos, and I'm just going to drag them over to pip. And I want to join them. This is a planetary. And I just might make it a little smaller. So I'm going to look at my input options. It's already debayered, so we don't need to do anything because it's set to auto detect. I don't want to limit the frame range because I want them all in the processing options. What I will do is just check to see if the size. So I just might make this 400 by 400. And test that. Yeah, that's going to work. Okay, so this is really the only enable object detection, reject frames. I'm going to turn that off. I want to crop it, and that's the crop. For my quality options, I'm not going to do a thing. For my animation options, I'm going to play all frames in the forward order. For my output options, I want to click on Ser, SCR. I'm going to create a subdirectory that will be in the directory where I'm getting all these files from, so that it'll be easy to find. And you'll see that there's 10,000 frames. So I'm just going to click on Start Processing, and it should zip through these pretty good. And while I'm talking to you, or while this is processing, I can tell you that one of the things that you will see that SharpCap is capable of doing is real-time stabilization. You can center the target on center mass, or if you want to, in Jupiter's case, you have 4 moons in the shot. You can center or track where the object's currently located. So that will keep the moons in the shot and not try to force the main body of the planet to the center of the image. Now, before we go, I'm going to do another file that will be on my Jupiter data. And this was the best Jupiter that I've ever gotten in 50 years of doing stuff like this. And it's not the best in the world, but for me, in my location, this is by far the best Jupiter I've ever gotten, as I've said. Now, when you saw me playing the Saturn data, you could see that the planet was jumping around a little bit. When I turn on stabilize, it's like magic. I mean, the thing just you would swear that there's something wrong with the program, because the thing just, boom, stabilized. And you'll see there's a little red box that will jump around, and that's the stabilization box. Okay, this is almost done. And it will write the file, which it did. We'll go and check. And it created a new file here. And I now have a new Ser animation. And if I just double click on this, it'll open up the Ser player. And you can see that that's my Saturn. So now what I want to do is go back. Whoops, I'm sorry. I want to click on my source, and I want to remove all these. And I want to find, what is it, 6, 10, 6, this one, this one. This is my Jupiter. So I think that's the one, but I just want to make sure. Yeah, we'll go back. So let me check this one. And maybe we use this. Okay. Okay, so I'm going to select all these files, drag them over, and I'm not worried about any of the moves. Okay. So we want to join the files. We want it to be in planetary mode. And as you can see, I'm going to use the same crop, which is 400 by 400. That's plenty good enough. We'll just make sure that nothing's changed. Nothing's changed. The output option still is Ser file. And we will process these. Now, Simon has asked, I believe, for some lunar and solar data, and this video would be a little too long to include that, so I'll have to do another video. I haven't been able to go through some of my lunar and solar AVIs to see which ones would be good for showing some of SharpCap's new features. Oops, did I not join? Let's see here. Pip is pip. I found that sometimes when you use pip, you have to close it and start it again, and it's don't know why. Automatic debayer, processing. We'll do 400 again. Test it. Looks good. Not doing quality. Animation is going to be Ser. And did I not select join? That's important. So it's going to take all those files and make one big one. Theoretically. And because there's 10 files, it should go, yeah, there we go. Perfect. Now, I have one more, so I'll show you Saturn, I'll show you my Jupiter, and then I was able to locate some Jupiter data from a D Ward on the Cloudy Nights forums. And I can't believe someone actually shot this from Earth. It is freaking gorgeous. And I'll process that for you. It won't take long because the data is that good. So this is what the main reason I'm doing this is because I want a lot of files to process, and 1,000, or I'm sorry, excuse me, 10,000 frames of each is about as close as I can get to a session, a night session, when I have clouds. But I'll be able to show you all of the features of the tool on SharpCap that we'll be using. In fact, I can open that up now. Now I'm using the latest version of SharpCap, which came out on January 8th, 2024. there's the file, so we're almost there. When you consider the how many files that this thing is processing, because it's got to put 10,000 frames into basically memory and then combine them into one big file. So it's doing it pretty quickly. And 10,000 frames, I forget how long this was. So that there's 1 minute, 2 minutes, 3 minutes, say 4 minutes of data at, I think it was maybe 45 frames a second. Okay, so that's done. So now we can close pip. We're done with pip. This is the file that it made. Just make sure it works. Yep, perfect. I mean, I've never seen, this is unstudied. That's how good my skies were. But you could see that even unstudied, I still have to deal with a lot of atmosphere because I'm up so high. I'm at 42, 43 degrees. And that's considering where Jupiter was in the sky. This is not too shabby. So let me go to here. And I think this is the file here. Now, this is the data that we will be looking at in SharpCap also. And this is a 708 by 618 8-bit image. And I don't know where this guy was shooting from, but it is gorgeous. Okay, so let's go to SharpCap. And to load in files to play with, you kind of have to use a trick. And that trick is to load the test camera 2 high-speed camera. And this is the image that comes up. And then in the testing controls, we're going to go and browse to get one of these files. And I want, which one do I want? 24. Uh, 7 and 8. Take 8. There it is. Okay, so you can see that as soon as you load it, it starts playing the animation. And if I want to stabilize this, I can go to the tools down below, and you've got planet disk stabilization. So I can turn it on there, and you can see that as soon as I do, the planet is now no longer moving, and we have like a little red outline, and that's the offset to show the program is now stabilizing. But we don't want to stabilize here. We want to stabilize in the tool Live Solar Lunar Planetary Stacking Enhancement mode. And you can see that we have all the information. I am currently stacking 800 frames. You can see them building up here. This is the frame stacking rate, so that's your frames per second. I'm going to sneeze. Excuse me. And to just show you that you can, to prove that this is a real-time stack, I'm going to turn it off, and you will see that there's our real image, and I'm going to turn it back off. So now what we want to do is we want to start processing. So I'm going to drag up the fine filter to somewhere around here. I don't want to go too far. The old rule of thumb, you go too far and then you back off a little bit. So I'm just going to back off because it definitely went too far. Somewhere around in there. And this turns on this whole window. So if I turn this off, you'll see all of the options get ghosted. This half wavelet scales, what it does is, and that's for these top two, it will double the size of the image, perform the wavelet scales, and then take that double back out and display here. So that's what we're seeing. And that sometimes gives you better results. It's something you'll have to play with. So now I'm just going to start tweaking the wavelets a little better, a little more. Now this is definitely not the best Saturn data that I've ever had. But for me, and where Saturn was on this particular day, it's not too bad. So if I come over here, I can adjust the brightness and channels. And you can see by the histogram that I'm a little bit off. Not too bad. And I'm going to bump the saturation a little bit. Red channel seems. Gotta get rid of blue, I think. Because I want the rings to be a little flatter. There we go. So that is a real time. You can see I'm only taking 800 out of the possible, I think it was 10,000. And we haven't even we've just gone past halfway on the thing. If I want it to look better, I can go to, say, 2,000. And you can see that now the stack is going up, current stack length. And I do have a little too much noise in here, so I can pull the denoise up. And again, this is not the best Saturn I've ever created. But based on this data, from there to there, I think that's a pretty big change. You can see my scenes going downhill. So it shouldn't use any of that. I think I'm going to make this 1,000. So you can change this. And what will happen is it will start going backwards, the stack, or I can reset the stack. Now the filter frame, or frame filtering, the tighter you get these two numbers, and I will show you the difference between my crappy data and better data, is these numbers get tighter. So my scene was really bad. So I really should only be taking maybe 50% to get the best data possible out of this. You can also make time lapses from your data. I'm not going to show you that here. Now the stabilization, I'm only using a single point, but you can go to multi-point. And because this is so small, I'm not really going to get into multi-point. You can pick based on planet full disk or surface for stabilization mode. I currently have it stabilized to center. You can track the planet with SharpCap selection area. That would be something along the lines of an ROI track. So let's just say I have my full frame sensor, and at my current 400 by 400 pixel ROI, that leaves a lot of sensor that if I had drift or for whatever reason, you can use the ROI as a track. So for however big your sensor is, the ROI can follow the target. I am currently realigning the color channels, mainly because I have a pretty big spread based on how bad my atmosphere was. And I can also rotate the image. So again, it is warning me that my frames per second are too low. Some of that is mainly because I'm doing the half wavelet scale. And that slows the frames per second down. If I turn that off, it goes up considerably. I can tweak on the colors as you were seeing. I can change the gamma, I can change the brightness. I think there we go. Probably was a little over saturated. And you can move each color channel. And of course you can saturate the data. So now that this is done, I can either save as a PNG or a 16-bit TIFF, this image. We won't do that. So I'm going to reset this. I'm going to reset this. And I am going to go to here. Now we want to go to the 6, 10, 6, this one. Jupiter. Which one did I take? 2? Yes. We're going to load this Jupiter. And because I had the tool open, it is tracking. So if I turn this off, you'll see it'll start jumping around a little bit. So it is currently stacking. I'm stacking 100 frames, or I'm sorry, 1,000 frames. So I'm going to start pulling up some features here. 0.8. Pull up the noise reduction. Saturate the colors a little bit. And because my Jupiter is flipped, I'm going to use the stabilization features to just turn Jupiter around. And we're at 800 frames. And I'm still doing the half wavelet scale. With smaller data like this, it usually works better. So like when I show you the other Jupiter data, the better Jupiter data, you will see the you will see how much nicer it gets. Now there's 1,000 frames in the stack, and I'm currently, where am I? Right here. I got 2,000 of the 10,000, so I might want to do 2,000 just to help the cause. I'll bring this up a little, maybe this up. Something like that. But I have never seen the little cyclones down here in either the upper or lower areas of Jupiter like this data is showing. Let's go down to the histogram, see what that's telling me. My reds are a little hot. My green's a little hot. There we go. I can just bring this in a little bit. If I want to add a little more contrast, I can move the mid slider to the left. Might be a little too much. I got 1,500 out of the 2,000 frames in, and I'm currently at 4,000 in the out of the 10,000. And what this will continually do is update. So it'll drop frames. But you don't want to have too many frames selected in here for a planet like Jupiter where you're trying to show moons, because the moons are moving fast and they'll start to streak on you. So you need to make a decision. Do I want to have solid moons and Jupiter? Or you can take two images, get the moons the way you want them, take an image, and then start a new stack to just concentrate on Jupiter, and then like in Photoshop or something, you can combine the images the way you want. So that is 2,000 frames in the stack, just to show you that this is a real time. That's the data. That's what it looked like. Turn it off. That's after the processing. And again, I'm at 42.3. So given the height that this was in the sky and the amount of atmosphere I was looking through, this is the best Jupiter I've ever gotten in the 50 years of amateur astronomy. So this one image made all my efforts at shooting Jupiter worth every penny of sweat equity I've got into this. So now what I want to show you is, I'll reset this, I'll turn this off. We'll go up here, go to downloads, oops, yeah. Jupiter, we'll just grab this guy. And I have the flip in, so we'll deflip it. Where's the browse button? Right there. So this looks like it's a lot of frames. So we'll start processing this. And you can see I've turned off the half wavelet series, mainly because this is a big image. It's 708 by 618. So I'm going to drag the slider to the right for fine. And I'm going to work on the noise a little bit. Might drag this up, not too much. Maybe, well, maybe not even. we'll just let this stack a little bit. I'll do an adjustment. We'll add some saturation. Let's go down and take a pick. It'd be a little hot in the red. Oh, that was gamma. Shoot. It was red. Green is a little hot. There we go. So we'll let this stack keep going. And again, if I turn it off, that's what it looks like. That's the processed view. That's what it looks like. And this is the processed view. So I'm just going to drag this up a little bit. So what I'm looking at is this edge. You can see there's a little ring there. So I'm going to just bring this down. Really don't need these. I'm going to restart the stack. And we've got display rate. So we're doing about 15, 16 frames per second being added to the stack. And again, this is not my data. This belongs to, I think his handle is D Ward on the Cloudy Nights forum. And I'll see if I can find the link and I'll post it below if you want to play with this data. And you can see here, 13.5 to 15.5. I mean, I would die for skies like this. In fact, I don't even need to, I could turn this off and take every frame. So I'll just restart the stack. Because we're talking 2 at the most. Big deal. But red is a little hot still. Into green. Okay, so that is D Ward's Jupiter. And coming up on 1,400 frames in the stack. And it will continually get better because his data is so good. I mean, from this to that is just, I would die to see skies like this. So again, this is SharpCap's live planetary stacking tool. And this would work for lunar and solar. For people that do solar, I have a cork. and it's got a 4 times Barlow in it. So with the scope I'm using, which is an AR-102, I'm zoomed into the surface of the sun fairly close, not as close as some, but it's still pushed in. I don't see the full disk. And the atmosphere, because I have the same problem with the sun, even in the summer, the sun gets, 69 degrees. It's still a lot of atmosphere to look through. And then by, 3 o'clock, I have so much atmospheric turbulence that it's not even worth going out. But with this stabilization tool, I mean, I can't wait to try it. And if we get views like this, in fact, let me just try bumping this up to 3,000. Let's see, because I'm not even, it just rolled over. So, but these tools, hard to believe that this one program, even if you used, say, Mellencamp Sky to capture Ser animation files, and then went to SharpCap, loaded that file in, you've just saved yourself so much time because you don't have to mess around in PIP. You don't have to mess around in AutoStacker. But I would still use IMPPG. I'm still not quite there with how I can use SharpCap tools, because I still want to use IMPPG. IMPPG is like the best solar sharpening tool there is on the planet at the moment. And you just can't beat it for what it is. So if you get a ring like this, what you can do is pull the black over. And what that does is it has a tendency to darken that outer edge. But it's still gorgeous data. So I hope this helps or gives those that would like to try SharpCap for uh, their lunar, solar, and planetary stuff a try, because to go from this to this, or from this to this, is unbelievable. Unbelievable. That's all I can say. So I would like to wish everyone clear skies, and we'll see you on the next one. Thanks.